Hi all. So we have a pretty small lecture today, so maybe 20 minutes or so. And what we are going to do today is Cramer's rule. So what we did in the last lecture was we found out how to use matrices to solve systems of equation. So for example, if we had this system of equation, what we would have done is converted it into this format, the matrix format, and then using this formula, we would have found the values of x1 and x2. So hopefully you've all understood how to do that. Hopefully you've all done the practice problems and you guys have some grasp about matrix inversion method. But you would have noticed that matrix inversion is a lengthy process. That is problem one. Problem two, as I keep telling you all, that it is very unlikely that when you're doing some real research work, you will be dealing with the 2 by 2 case. Oftentimes you'll be dealing with 5 by 5, 10 by 10, 20 by 20 case. And when you're doing that, it may be that you don't really need to find all the values of all the variables. So suppose you have x1, x2, x3, and so on until x20. We have 20 variables, so we're dealing with a 20 by 20 case. But suppose you just need to find the value of x7 and x15. These are the two you need. Now, if we are going down the route of matrix inversion, it's a very long process, and at the end of it, we are finding values of all the x's. So we don't really need to do that. So what we need is a simpler method, and that simpler method is the Cramer's rule, which allows us to find the values of the specific variables. So in this example, for example, x1 and x2, if you use matrix inversion after the lengthy process, we are going to have the values for both x1 and x2, but through Cramer's rule, it's possible for us to find the value of only x1 or only x2. So let's look at how that works. So the first step is the same, to make sure that the matrix is square. So we have matrix A, which is 5, 3, 6, minus 2. So is this square? It is square. And the second step is to make sure that this is a non-singular matrix. So determinant of A is equal to 5 times minus 2 minus 3 times 6. So what do we get here? Minus 10 minus 18 equals to minus 28, which is of course not equals to 0. So therefore, we know that A is square and non-singular. Okay, now we're going to do something different. We have matrix A. We are going to construct matrix AX1, or let's just call it A1, and matrix A2. Okay. So matrix A, let me write the matrix A. So we have 5, 3, 6, minus 2, and here again, 5, 6, 3, minus 2. And now what I'm going to do is I'm going to replace the first column of A1 and the second column of A2 with this matrix, okay, 30 and 8. So we get 30 and 8 here, we get 30 and 8 here. And now let's calculate the determinant of A1 and A2. Okay. So the determinant of A1 is 30 times minus 2 minus 3 times 8. So this is minus 60 minus 24. minus 84. And A2, determinant of A2 is 5 times 8 minus 30 6. So this is 40 minus 180, so minus 140. So what are the three things we have? We have determinant of A, we have determinant of A1, we have determinant, and that is all we need for Cramer's rule. The value of x1, well, that's a horrible looking x. Value of x1 is the determinant of A1 divided by the determinant of A, which is equal to minus 84 divided by how much was determinant of A? 20 minus 28. Minus 28. That is 3. And the value of x2 is determinant of A2 divided by the determinant of A. So that is 140 divided by minus 28. So we have 5. And that's it. We found the values of x1 and x2. So this is obviously a much simpler method than matrix inversion, but you will still need to know both the methods. And during exam, I am going to specify which method you have to do to find the values of x1 and x2. So Cramer's rule is simpler method, but there are some very specific reasons why we need to know the matrix inversion method as well. Now, we're not going to go into details about what those are in this course, but you need to, all I'm saying is you need to know both the methods. Okay, so this was a 2 by 2 case. Let's take a look at a 3 by 3 case.